Hi everyone. Here I am going to discuss about a very important topic in measurement system, that is a Bourdon tube. So what exactly it is? So this is a pressure transducer, means it converts one form of energy into other form. This means this commonly used for measuring the gauge pressure of both gases and liquid fluids. So this is a classified as a mechanical pressure measuring instrument, and this is invented by the Eugene Bourdon in 19th mid 19th century of the year 1849. That's why this name is the Bourdon tube. So next one is this is a primary sensing element. Why? Because this is used to measure the pressure at primary stage, and it operates without any electrical power supply. So the pressure range over which it operates, that is the high pressure range, that is 0.8 to 10,000 psi, and in bar 0.6 to 7,000 bar. So now this principle, the principle is when elastic transducer is subjected to pressure, it deflects, and this deflection is proportional to applied pressure when this is calibrated. Means when Bourdon tube are made up of the elastic material which converts the pressure into mechanical displacement, and then this displacement is converted into electrical signal using the electrical transducer, and this output of electrical signal is nothing but which is proportional to the applied pressure. Now this is a construction. So here we can see the basic diagram or a schematic diagram of Bourdon tube. So the materials such as phosphor, bronze, steel, beryllium, copper, these materials are used for construction of Bourdon tube. Why? Because they have good elasticity property, means they can deform easily when pressure is applied and regain to its original position when pressure is removed. So this is constructed as a, means it consists of long thin walled cylinder, have a non-circular cross section which is sealed at one end. So they have two end, means this Bourdon tube has a two end. One is here, means this is a fixed end, and other one is the free end. So this fixed end, that is the pressure input, is given to this socket which is soldered at the base of the tube, and second one is the free end which is closed, and this is closed by the tip. So and this tip is connected to this segmental lever through this adjustable link, and then this pointer is connected to this spindle, and this spindle is connected to this sector also. So this segmental lever is suitably pivoted and the spindle holds the pointer. So this pointer moves on this scale which shows the amount of pressure applied. So here spindle bearings are there. Because of this, friction occurred, and due to this error will produce, and this error is known as the lost motion. This is a big disadvantage of the C-type Bourdon tube. Now working. So how it works means the fluid whose pressure to be measured, which is applied through this pressure inlet, we can see from this figure. So when fluid under pressure enters to this Bourdon tube, then it tries to change the cross section of this tube from oval to circular and then straighten out the tube. Okay, so this movement provides the displacement of this pointer which is proportional to the applied pressure, and this displacement is measured with the help of transducer. Means this gives the this converted into electrical signal, that is current or voltage, and this output is nothing but the applied pressure. This is a very simple working of Bourdon tube. Now the advantages: cost is less, means low cost, then construction also simple, then used for high pressure range application, good accuracy, and easily adapted for the design for obtaining the electrical output. Now the disadvantage: this is subject to hysteresis, then susceptible to shocks and vibration, then it gives very slow response to change in pressure, means tip movement is very slow. One more disadvantage is the lost motion. Error will produce due to this bearings and linkages are there, and this also limitation of C-type Bourdon tube. These are the limitation of C-type Bourdon tube. Now the types of Bourdon tube. There are three types: C-type Bourdon tube, spiral Bourdon tube, and helical Bourdon tube. So already I have explained this C-type Bourdon tube. So there are some limitation disadvantages in C-type Bourdon tube. That's why this spiral and helical Bourdon tube are designed. So first we will see this spiral Bourdon tube. So from this figure we can see the construction of spiral Bourdon tube. They made by winding a partially flattened metal tube into the spiral having several turns. So there are number of turns are there. There is one limitation in C-type Bourdon tube. There is a they give the very slow response when pressure changes. But here this tip movement is very large. Why this tip movement is more? Because this tip movement of spiral equal to the sum of all tip movement of individual C bend arcs. Therefore, it produces the greater tip movement than the C-type Bourdon tube. The principle is same as a C-type Bourdon tube, but here this tip movement is more. Means as pressure increases, then this all spiral turns will uncoils. So that's why this mechanical amplification is not needed, and because of this, no lost motion from loose this gears, levers, and sticking links. Okay, so here tip movement is large. That's why we cannot use for high pressure application. So this spiral Bourdon tube we can use for low pressure application. So because of this all things here sensitivity and accuracy is also more than this C-type Bourdon tube. Now this helical, here helical Bourdon tube, this constructed like this wound in the form of helix and allows the tip movement to be converted into circular motion. How? By installing there is one shaft, or this one is the shaft inside this helix. Okay, and this connecting to tip. So this shaft is connecting to tip. So as this shaft rotate in circular motion, then tip movement also become the circular motion of the shaft. Okay, so these Bourdon tube have greater means more tip movement than spiral type. Okay, so this used for high pressure application, means high pressure helical types might have as many as 20 coils, and low pressure helical types might have 2 to 3 coils. So as coils increases, then this tip movement will decreases. Okay, means the change in the tip motion decreases as applied pressure becomes large. Adding more coils compensate for the motion motion decreases. Means as we add the more coils, if we want to measure high pressure, then this tip movement will decreases. Okay, so they also have a this type also has a more sensitive and accurate than C type Bourdon tube. So there are some advantages of spiral helical types over the C type Bourdon tube. As I told you, they both have they both these both are more sensitive than C type Bourdon tube. And one more thing is they manufactured in very small sizes. So because of that size, we can use in any application, for example recorder controllers. But this C type Bourdon tube we cannot use for this application because of this size is not suitable for this application. Now the applications of all C type Bourdon tube, then helical and spiral types. So we can use for gas distribution system, then hydraulic pneumatic installation, automotive system, vehicle tube tire, gas distribution, like this. There are many application uses of Bourdon tube. So thank you for watching this video. So if you like this video, then don't forget to share, comment and subscribe to my channel.